Welcome to Graco's lubrication equipment installation training video. Throughout this video, you will see example activities that are performed on traditional automatic lubrication equipment installations. Though your specific equipment may differ in brand or design, the installation process is very similar. On a typical excavator, there are several bearings and bushings that need to be lubricated. To familiarize yourself with each component, let's review the name for each part. On the work tools, you have the bucket pin, H-link pin, bucket link pin, and bucket cylinder rod end. On the stick or secondary boom, you have the second bucket link pin, bucket cylinder foot pin, boom stick pin, and stick cylinder rod end. On the boom, you have the stick cylinder foot pin, boom cylinder rod ends, and the boom pivot pin. Lastly, on the chassis, you have the boom cylinder foot pins and the swing bearing. Graco lubrication equipment kits provide the standard components you would need for a typical installation on mobile equipment. This includes hose fittings, lube point fittings, metering devices, metering device fittings, mounting hardware, retaining hardware, electrical cables, electrical connectors, and the lubrication pump. Before initiating the installation, be sure that the equipment is positioned in a way that there is access to the work area in a safe and secure manner. The installer begins preparing the machine by removing any pins that could become damaged during the lube point drilling process. This is not always necessary if you are simply attaching the lubrication dispense hose to the lube point directly. This practice is common where there are areas that damage to the lubrication system could be a concern, and the location of the lubrication point needs to be moved. This will increase the life of the lubrication equipment. It is important to protect the factory components on the equipment. Using heat or impact guards to protect components during the assembly, disassembly, and modification stages is critical. This individual is rotating the H-link to allow for simplified access to the various parts of the excavator and to streamline the installation process. As you can see, he's moving the hydraulic cylinder to allow for more space in the work area. He is also taking care to protect the equipment from impact damage by using spacers and protective covers on the polished hydraulic cylinder. This particular excavator has a third spool valve on it with a quick attach coupler. This requires the removal of the hydraulic hoses to the quick coupler, which will help reduce the potential for damage to components during the installation process. Be sure to clean up any potential spills to reduce contamination and to maintain a clean work environment during the installation process. Begin by drilling pilot holes where any modified lubrication points will be moved. On this application, there are the bucket pin, bucket link pin, and the H-link pin lubrication points. The individual temporarily installs the pivot pin to aid in the greasing process. By manually greasing the lubrication points, he can validate that he has drilled the new lube points properly. This also aids in purging out any contamination that may have accumulated during the drilling process. The installer progressively increases the lubrication point holes until they meet the desired size for future component installation. This may take several attempts until the desired hole size is reached. The installer then uses a longer drill bit to penetrate the bucket link pin cavity, which is located inside the casing of the stick. The installer needs to create threads in the newly drilled lubrication points by using a properly sized thread tap. Each lube point needs to be threaded in order for lube point fittings to be connected properly. A threaded tap extension may be required to reach certain lubrication points. Next, the installer marks out the location of the mounting hardware using a paint pen or marker. There are multiple locations that will need to be marked to help retain hoses and valves on the equipment. The location of these components depends on the rotation or articulation of the equipment that is being installed on. It is important to route components in the same fashion as the factory design. This ensures reliability of the installation and makes for a clean and professional appearance. There are several hoses that articulate in a lubrication system. It's important to retain these hoses using hardware to reduce the potential for damage due to abrasion, stretching, binding, or breakage. With proper tools, remove the paint around the area the mounting hardware was previously marked. The purpose of this process is to remove the paint to allow for a clean metal surface to be exposed. This is necessary during the installation process, as the installer will need to weld the mounting components onto the equipment. If there is excess paint in the welding area, then the weld will not form properly, resulting in an inadequate installation. In this example, the installer is adding additional protection components not supplied by Graco. This requires additional modification to the equipment which are not covered in our standard installation manuals. The installer is threading special tubing that will be installed onto the lubrication points at the end of the boom. These threads match the same thread size as previously used on the lubrication point. After applying thread sealant, the installer screws the threaded tube into the tapped hole of the bucket link pin. Using a hand tool, he tightens the threaded tube until secure into the lube point. The installer welds the threaded tube to the frame. This secures the tube in place and reduces the chance for loosening of the fitting in the future. By applying a heat source, the installer is able to modify the angle of the steel tubing. This allows the use of one continuous piece of tubing and improves the reliability of the installation. Similar to the bucket link, the installer screws threaded tubing into the tapped hole of the bucket pin. The installer welds the threaded tube to the frame. This secures the tube in place and reduces the chance for loosening of the fitting in the future. By applying a heat source, the installer is able to modify the angle of the steel tubing. This also allows the use of continuous piece of tubing and improves the reliability of the installation. The installer welds the tubing to the frame. This secures the tubing to the frame and improves the reliability of the installation by reducing potential damage in the future. Once again, the installer applies a heat source to the tubing to modify the angle of the tubing. This time, it is to cut the tubing to length and allow for the proper mating compression fittings to be installed. Next, the installer mounts the weld mount brackets for the Graco CSP metering valves. The location is important to allow for future addition of hoses and fittings on the valve assembly. This component has a higher weight than others and would require additional welding to secure properly. Similar to the other components, the retaining hardware that was previously marked will need to be welded in place. This secures the mounting hardware and ensures proper routing of the dispensing hoses on the equipment. Be sure to protect any components from damage. After the welding process is complete, the installer will clean the welding areas with a solvent to remove any dust or contaminants from the surface. He protects any areas that need to be covered to eliminate overspray from the painting process. The installer applies a base coat of primer to the surface of the equipment where the paint was previously removed. This provides a level of corrosion protection and helps the paint cover the surface properly. After the primer has dried, the installer applies a top coat of matching paint to the equipment to return the equipment to its factory appearance. There is typically more than one metering device installed in a lubrication system. Following the pre-configured design specifications, the installer inserts and tightens the inlet fittings, outlet fittings, and any plugs into the metering valve assembly. The installer uses the proper torque specifications that can be found in the metering device manual. Graco offers a variety of fittings that can be used to configure the design to your specific application. G3 pump assembly consists of combining several fittings by use of thread sealer to reduce any leak potential. The installer combines a series of bushings and T-fittings to modify the angle of the lubrication dispense. He then installs the fittings into the pump element outlet port on the side of the pump. Once the outlet fittings are tightened, he installs a pressure relief safety valve to allow lubricant to purge from the system in the event that overpressurization occurs. This should be installed on every lubrication system, regardless of configuration. The final outlet fitting is then installed, which allows a grease hose to be connected to the outlet port. Lastly, he installs an optional quick fill stud to allow for faster refilling of the grease pump reservoir. Once the pump assembly is complete, the individual fills the reservoir to the proper level in preparation for future installation. It is important to note that the filling of all components, including the pump, metering devices, and any hoses, are required for the lubrication system to function properly after installation. The individual identifies all lubrication points by walking around the equipment. He then removes all grease zerks that are installed on the factory equipment and replaces them with the proper lubrication point fittings. These fittings could be elbows, straight fittings, 45-degree fittings, or even reducing fittings. The installer uses a thread sealer to ensure that the fittings will remain intact and to reduce the potential for future leaks. Orientation of the fittings is important to ensure there will be no interference with the factory installed components on the equipment. Graco provides a range of high-pressure hoses that can be used to transfer lubricant from the pump to the metering device and then to the lubrication point. Using proper hoses is essential to the reliability of the lubrication equipment. Here, the installer is routing hoses from where the metering valve will be mounted to the lubrication point. He carefully routes the hoses across the previously welded mounting hardware to the lubrication point. This is to ensure he has the proper length required to connect the hoses to the valve and to the lube point without any interference with the existing factory components on the equipment. Using proper hand tools, the installer cuts the hose to length. He then installs a hose sleeve in counterclockwise rotation in accordance with the installation instructions in the manual. Utilizing lubricant during this process simplifies the installation. Once the hose sleeve is installed properly, the installer inserts a lubricated hose stud into the hose sleeve. Using proper hand tools, he tightens the hose stud into the hose sleeve in accordance with the installation instructions in the manual. To simplify the installation, the installer is inserting his custom-built hoses into the pre-configured valve assembly. He is taking caution to verify that his hoses match the metering device outlet configuration. This is important to ensure proper lubricant dosing is achieved for each lubrication point. He tightens down the lubrication fittings to the recommended torque specifications in the metering device manual. The installer then mounts the metering device onto the previously welded mounting plates. He uses the proper mounting hardware and torques the hardware to the recommended specification in the metering device manual. In areas where potential abrasion may be a concern, the installer wraps the hose with an abrasion-resistant hose cover to reduce potential damage during equipment articulation. This hose cover is cut to length in accordance with the length of the hose that is being protected. The installer repeats this process for all hoses that require additional protection. Once the hoses are ready to be installed, the installer prepares the previously welded mounting hardware to accept the hoses. He then routes the hoses through the hardware, installs the remaining components, and then secures them with the proper tools. He repeats this process until he has the hoses installed into their final location. They're routed correctly to the proper lubrication points and are oriented in the correct direction. Once the hoses are routed to their correct location, you will notice that the other end of the hose was not assembled. Extra length of hose was left here to allow for final assembly to the lubrication point. This ensures the hoses are cut to the proper length and not installed too short or too long for the application. Following the hose fitting installation instructions, the installer adds the hose fittings to the hoses and secures them to the lubrication point following the recommended torque specifications found in the manual. The installer repeats this process for all lubrication points on the equipment. The installer begins reassembling the work tools on the excavator by reinstalling the bucket link plates, the bucket link pin, and securing the assembly to the manufacturer's specifications. To aid in the grease filling process and to help purge out any potential contamination from the steel tubing that was welded, the installer temporarily attaches grease zerks to the tubing. This is to allow him to pump grease using a Graco manual grease pump. The installer pumps grease through the steel tubing until grease can be seen purging from the pin bushings on either side of the boom. He repeats this process for the bucket pin to ensure proper lubricant flow and to remove any potential contamination from the installation process. The installer then inserts the final attachment fittings for the steel tubing using special compression unions. He installs these components to the manufacturer's specifications. The installer then retains the delivery hoses using cable ties to ensure the hoses are protected and routed into their proper location. Following the procedures before, the installer cuts the hoses to length, installs the hose fittings, and attaches them to the lubrication points following the proper torque specifications in the manual. The installer reattaches the third spool hydraulic hoses that were previously removed to allow for additional workspace. He follows the factory specifications to ensure proper installation. The installer is now attaching the work tool metering device to a custom-made mounting bracket manufactured by the installer. Following the same process as before, he has installed the hoses into the valve to simplify the installation process. The installer mounts the custom bracket into the center of the H-link of the work tool. Here, the metering device will dispense lubricant to the remaining work tool lubrication points. He secures the bracket using his recommended mounting requirements to ensure proper installation is achieved. As performed before, lubrication point fittings are installed into the newly located lubrication ports on the H-link. The installer rotates these fittings into their proper orientation to ensure the hoses are at the correct length. He torques the fittings to the recommended specifications. As performed before, the installer takes care to measure these hoses correctly. He cuts the hoses to length. He installs the hose sleeve. He installs the hose stud and secures the hose to the lubrication point. He then tightens the fittings to the recommended torque specification. He repeats this process for all lubrication hoses on the work tool metering device. Similar to previously mounted components, any hoses that may be subject to abrasion during articulation should be covered with a protective guard and secured properly using cable ties or retaining hardware. The installer then articulates the machine to allow for complete reassembly of the work tools and final assembly of the work tool metering device on the excavator. He reinstalls the H-link pin into the bucket attachment and secures the pin to the factory specifications. After rotating the H-link, he then installs the additional hoses for the H-link, secures them with mounting hardware, and articulates the equipment to allow for additional access to any remaining hoses on the boom. The installer then repositions the boom to allow for simplified access during the primary feed hose installation process. A primary metering device is used to distribute lubricant to secondary metering devices remotely located on the equipment. The primary metering device hoses are installed in the same fashion as the lubrication dispensing hoses, except you are installing the hoses to the remote valves rather than the lubrication point itself. The common practice is to route the primary feed hoses parallel with the existing hydraulic hoses on the equipment. They are typically secured using cable ties or other mounting hardware to ensure proper installation. The installer is now mounting a custom-made mounting bracket manufactured by the installer. This mounting bracket has both the primary metering device and a secondary metering device attached to it. The installer uses existing hardware on the equipment to mount the custom bracket onto the boom. As previously explained, the installer removes lubrication zerks on the boom to allow for installation of the lubrication point fittings. Proper orientation is required to allow for a clean and professional installation. The installer uses cable ties to secure the feed hoses to the lubrication points. He cuts the hoses to length, he installs the hose sleeve, he installs the hose stud, and secures the hose to the lubrication point. He then tightens the fittings to the recommended torque specifications and repeats this process for all remaining lubrication hoses on the boom. Occasionally, several hoses are being routed to the same area. Larger hose guarding can be used to route multiple hoses at the same time. The installer secures these hoses using cable ties and routes them to their proper lubrication point. The common practice is to route the dispensing hoses parallel with the existing hydraulic hoses on the equipment. They are typically secured using cable ties or other mounting hardware to ensure proper installation. It is important that the hoses are secured properly to ensure they do not become damaged during machine articulation. The proper length and routing of the hoses can change depending on the brand of equipment the lubrication system is being installed on. He cuts the hoses to length. He installs the hose sleeve. He installs the hose stud and secures the hose to the lubrication point. He then tightens the fittings to the recommended torque specification and repeats this process for all remaining lubrication hoses on the boom. The installer is now attaching the primary feed hoses to the primary metering device. He makes sure to connect the hoses to the correct outlets on the primary metering device to ensure proper dosing to the secondary metering device. He secures the components with cable ties. There are additional lubrication points for the boom and carrier located below the boom. The installer articulates the excavator to allow for additional access to these points. As previously explained, the installer removes lubrication zerks on the lube points to allow for installation of the lubrication point fittings. Proper orientation is required to allow for a clean and professional installation. Once again, the installer uses hose guard and cable ties to secure the feed hoses to the lubrication points. He cuts the hoses to length, he installs the hose sleeve, he installs the hose stud, and secures the hoses to the lubrication point. He then tightens the fittings to the recommended torque specifications and repeats this process for all remaining lubrication hoses on the boom. The installer is now going to install the pump onto the chassis of the excavator. The location he has chosen is to mount the pump on the handrail on the platform of the excavator chassis. He begins by removing the handrail from the chassis. The installer has manufactured a custom pump mount bracket for this installation. He secures the bracket to the handrail and marks his mounting holes. Using the bracket as a template, he then drills the required mounting holes and installs the bracket with his supplied hardware to the handrail. After reinstalling the handrail on the chassis, the installer mounts the pump to the pump mount bracket using the supplied hardware with the pump. He secures the pump and tightens the hardware to the recommended torque specifications. The pump power cable is attached to the pump. The primary feed hose is attached to the pump outlet fitting and tightened to the recommended torque specifications. The pump power cable is then routed through an existing rubber grommet on the chassis. It is then routed through the center of the chassis towards the primary power supply on the excavator. The installer is going to begin wiring the pump to the power supply by trimming the power cable to the required length for the installation. This pump requires the installation of both a negative grounding wire and a positive power wire. He begins by removing the protective cover on the wires to allow the installation of electrical connectors. He then installs a crimp coupler onto the positive power wire and secures it with the proper hand tool. To simplify the installation, he is using an inline fuse assembly to connect the positive power wire to the switched power supply on the excavator. He inserts the fuse assembly into the crimp coupler and secures the wire using the proper hand tool. On the other end of the inline fuse assembly, he attaches a ring crimp connector. He then secures the ring crimp connector using the proper hand tool. The installer also attaches a ring crimp connector to the negative power wire on the pump. He then secures the ring crimp connector using the proper hand tool. Next, the installer removes the positive power cable that is switched on during machine operation. He also removes a bolt on the chassis frame that can be used to ground the negative power wire on the pump. He installs the negative power wire by inserting the bolt through the negative crimp connector. He then reinstalls the bolt to the chassis and secures the bolt with the proper hand tool. He then attaches the positive power wire with the inline fuse assembly to the mounting bolt of the switched power supply. He then reinstalls the bolt to the power supply and secures the bolt with the proper hand tool. Lastly, the installer inserts the correctly rated fuse for the pump into the inline fuse assembly. He closes the cover to protect the fuse, which completes the wiring process for this application. To initiate the programming sequence, the installer holds the two middle buttons on the G3 pump for 3 seconds. He then uses the left and right buttons and the up and down buttons to program his desired runtime for the pump. He also programs the pause or off time and completes his programming by exiting the programming sequence. The installer then turns the pump on by running a manual lubrication event. This is to ensure the programming was successful and to begin purging lubricant through the hoses and metering devices. More information regarding the programming sequence can be found in the equipment manual. The installer inspects all hoses and verifies that lubricants are being dispensed properly. After the installation is complete and the installer has verified that all locations are receiving proper lubrication, the machine is articulated to inspect the hoses, metering devices, pump, and wiring. This is to ensure that all components have been installed correctly, there are no interference or clearance issues, and the hoses have the proper length to reduce potential damage in the future. Additionally, it is important to inspect all fittings and mounting hardware to verify they have been properly secured to the equipment. It is common practice to run multiple manual lubrication events to validate that there is proper grease flow through the pump, metering devices, and hoses. Quality installations are essential to the success of lubrication equipment performance. If the lubrication equipment is installed properly by a qualified technician, then the system should function seamlessly as part of the equipment's daily operation.